Okay, you guys, so we're just returning, we now have a function g, and I just realized I made a huge mistake, right? I'm referencing the function g, and then down here everything is back to f. So I apologize for that, right? Let's just make that g, and 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 g, 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 and g, right? So otherwise we would have been just using the function that we had up above there. So I apologize. But again, getting used to the notation, you notice in the first round, right, whether it's g of 5, g of negative 3, g of 0, right, I'm letting you know what x is equal to. So what's the output? What's the y when the input's 5, right? What's the output when the input's negative 3? What's the output when the input's 0? So that is easy enough. We just go to our function, we plug it in, we get the square root of 9 minus 3, 3 minus 3, we get 0. So g of 5 creates an output of 0. So again, if we were graphing this, I know that 5 zeros on the graph, right? When the input's 5, the output's 0. G of negative 3, again, we just go to our function, put it in, get the square root of 1, that's 1 minus 3, we get negative 2. So g of negative 3 is negative 2. And again, graphically, that just means I have the point negative 3, negative 2 on my graph. All right, so that's all we're doing. G of 0, well, again, we're replacing the x with 0. We get the square root of 4 minus 3, which is 2 minus 3. We get negative 1. So g of 0 is negative 1. Again, if we were graphing, this function would have the solution point 0, negative 1 on it. It's essentially its y-intercept. So there you go, that first round of give the input, go find the output. And we simply do what we've always been doing. You put the x in and evaluate. Getting a little stranger, g of a. Well, again, all we're doing is replacing the x with a. So go to my function, make that replacement, and that's all I can do with that, right? That's just a plus the square root of a plus 4, take away 3. So not much going on there. Here we're replacing the x, right, with negative x. And so I'll just go to my function, replace that x with negative x, and that's about all I can do with that. If you wanted to do anything, I guess you can rewrite that as 4 minus x, right? That's another way of saying negative x plus 4, but there's really not much more I can do with that expression. That's essentially it. Now, this is a little bit of a train wreck, I apologize, but again, what we're talking about is we're negating whatever g of x is. So g of x, let me put it in parentheses, is the square root of x minus 4 minus 3, and we're putting a negative in front of it. So this negative is impacting all of what g is. Well, there's what all of g is, and we're putting a negative in front of it. We're not inputting it like we did here, right? It's outside of what g is. So it's not being in, it's placed outside. Distributing, we end up with negative square root of x plus 4 plus 3. So there would be negative g of x. We're just negating y values. Okay, what about the x minus 5? Well, again, if I replace it, we've got x minus 5 plus 4 and minus 3. So I'm replacing that x with x minus 5. We can clean that up. I think we end up with x minus 1 minus 3 in there, right? Because negative 5 plus 4 is negative 1. So there would be g of x minus 5. What happens if I replace x with 5x? Well, you just have 5x plus 4 minus 3. And that's all I can do with that. What happens if I replace x with x plus h? Well, we get the square root of x plus h plus 4 and minus 3. There's no terms that are alike in there. So dropping parentheses, right, that's the best I can do with that. So g of x plus h is basically the square root of x plus h plus 4. And on and on and on. So input, right, do what we can when we input that. Back to the slope idea, again, the bottom's pretty easy to find. 21 take away 12, I believe, is 9. But the top requires me to find two output values, right? G of 21 and G of 12. So off to the side here, G of 21, that's the square root of 21 plus 4 minus 3. that becomes the square root of 25 minus 3. 5 minus 3, we get a 2. So that evaluates out to 2. What about g of 12? Well, that's the square root of 12 plus 4 minus 3. Square root of 16 minus 3. 4 minus 3, that gives us a 1. And so 2 minus 1 is 1. And we get an evaluation of 1 over 9. And again, what we've just found there is what's called an average rate of change, or what you guys know as slope, thinking in terms of lines, right? y2 minus y1 all over x2 minus x1, right? We'll actually explore that a little later. Last two, k, g of x is equal to 0. So this time I'm not telling you what the input is, I'm telling you what the output is. So we have to find the input. What input creates that output of 0? So I'll go to my function. We basically have x plus 4 minus 3. When is that equal to 0? And we're essentially now solving a radical. So we'll add 3 and get the square root of x plus 4 equals 3. Clear the radical by squaring both sides. We get x plus 4 equals 9. Subtracting 4. And it looks like we get an input of 5. So 5 is the input that creates an output of 0. All right, and again, easy to check. 5 plus 4 is 9. Square root of 9 is 3. Minus 3 gives us 0. So there's your input. Same thing here. Y is equal to 8. So I'll take my function. In this case, it's the square root of x plus 4 minus 3. And I got to figure out when does that equal 8. Again, it's another radical. So we solve that by isolating the radical, squaring both sides to get rid of the radical. We get, I think, 121, subtracting 4, and in this case we get 117. Alrighty, so there is your function notation, whether you're putting something in, whether it's a nice neat number, whether it's an expression, right, whether it's impacting the function, right, or whether it's solving an equation, right? So make sure you know whether we're inputting something or if we're trying to find the input. Right, so g of x equals 0 as opposed to g of 0. Two completely different stories, as you can see. Alrighty, so good luck with your homework. Obviously, ask questions if you got them. Get used to a lot of these, even these little crazy ones, even if you don't like it, because that's going to build some more math later on, right? Even in odd functions, transforming functions. So get used to putting things in, right, that aren't just nice, neat numbers. All right, builds lots of math. See you guys in the next video.